Inertia, Newton's first law of motion. It states that an object that is at rest tends to be at rest, or an object that is in motion tends to be in motion. Okay, minor correction. I was supposed to say that uh, an object in motion tends to stay in motion in this at the same speed in the same direction, unless acted upon by an unbalanced force. What does that even mean? Well, it would be easier to explain it with a couple of demos. Yeah. To demonstrate inertia, what you can do is you can do this demo. The objective of this demonstration is to show how inertia works on an object as it spins. What you need for this demo is a half full bottle of water, more or less here or more, or it can be any liquid. Now, what you're going to do is you're going to hold the bottle of water straight with your arm straight, and what you're going to do is that you're going to gain momentum by swinging it, and when you're ready you can actually spin the bottle a full circle without spilling any water. So why didn't any water spill? That's a great question actually. Well, let's go back to the experiment, the demonstration again. You're holding the bottle like this, and right now it is in a state of rest, but then you apply an unbalanced force on it, so it becomes in motion. So that's inertia, but that's not the whole thing, right? Now, in reality, the water here actually wants to fly off in a straight direction. So let's say we stop here. The water actually wants to fly off this way, making a tangent from the circle that we're trying to make. Wants to escape the circle. Why does it want to escape in a straight line? Because of inertia. It's in motion and it wants to stay in motion at the same speed in the same direction, and the direction is straight. Now, why doesn't it just go? Because of the walls of the bottle. The normal force the normal force of the walls of the bottle are stopping it from escaping and redirecting it into a circle. Both of these forces cause the water to push on the walls of the bottle, keeping it there, keeping it inside the bottle. So that works even when it's fully upside down if you spin fast enough. So yeah, like that. That's why it doesn't fall. But you have to spin it fast enough, because if you don't, it'll just spill, and we don't want that. If you don't spin fast enough, why would it fall? Because gravity will overcome the inertia of the water, and that would bring it down. That's why it would spill. So that's how inertia works here. Okay, so the second part of the physics demo, it's gonna be a little bit more fun, I guess. The objective for this demo is to show how an object that is in motion tends to stay in motion unless acted upon by an unbalanced force. We're gonna use those. First, we need a wheel with chairs, some heavy books over there, and a sturdy chair. And basically, this is what's going to happen. Let me just position the camera. Okay, alright. You're going to take the chair with wheels and put the books there. What you're going to do is you're going to try to have a lot of momentum that it crashes into the sturdy chair and then the books slide off to the sturdy chair like this. Just like that. So what happened? Why did the book slide off to the sturdy chair instead of just staying on the chair with wheels? Well, inertia. The law of inertia states that an object that is in motion would tend to stay in motion unless acted upon by an unbalanced force, right? So let's take a look back at our setup, right? Here we can see the chair with the wheels and the books are in a state of rest. But then, when acted upon by an unbalanced force, they start moving, right? Now, when that moves and it rams into this chair over here, the normal force of this chair stops it from moving again, stopping it. So that's the unbalanced force. However, as you can see, the chair only contacts the chair with wheels and not the heavy books. So the heavy books keeps on going in motion until it slides off to here. Why? Because there is no unbalanced force on it except for friction, but friction here is very small. This is just a demonstration that objects in motion tend to stay in motion. Okay, so that's it. I hope you learned something from this today. Goodbye.